Juan. I'm at work. I have my headphones on, so hopefully you'll be able to hear me. So if you look at, go to week 4 folder and open up your RT lesson 15. Of course, the other ones have other charts, but I'm going to use this as an example to figure out a problem. And so we're going to use a chart. You need to have a chart so that you can resolve a problem. In the test or in the quiz, there has to be some kind of chart showing you how to resolve for a problem. So you could probably reference the charts when you look at your problem in your quiz. You could probably go back and reference the charts. So here's how I'm going to try to work it. It's one of the problems shown in there. So here's the word problem. Okay, here's the example of what they want you to find. So I'm going to read it first, and then I'm going to break it off in little sections. So here's the problem. If you had a Fourier Curie source of IR 192 and we're going to radiograph 2 inches of steel with a source to film distance of 20 inches, what will be the exposure time that would give a density of 1.5? So 1.5 is part of your formula that you're going to use. So don't pay attention to if you had a 40 Curie, don't pay attention to the 40. And it says if you had a 40 Curie source of IR 182, don't pay attention to 192. Just pay attention to 2 inches of steel with a source to film distance of 20 inches. So you're going to use 2 inches, you're going to use the 20 inches, and you're going to use the 1.5 inches. Now, how do you know to use 1.5? Or how do you know what the exposure factor is going to be? Okay, that's so, because here's the formula. Formula is time equals exposure factor times distance squared, okay, divided by, and then divided by I is the answer that you're going to get from exposure factor times diameter times distance squared. So that's how you're going to get that I. Okay, write down this formula. Time equals EF times D2 divided by I. So it'll look like EF times D2 and then a line, and then underneath will be the I. Okay, so here's how you get the your numbers to plug in. So first of all, you need to find the exposure factor. So how do you get the exposure factor? The exposure factor is going to be found by going to your chart, and the chart shows a density. It shows a density of 1.5. It shows a density of 2.0. It shows a density of 2.5. Well, you know that you're dealing with 2 inches of steel. Again, 2 inches of steel with a source film to a distance of 20 inches. So the 2 inches of steel underneath the chart, it runs horizontal on the bottom, steel inches, and the chart on the left shows exposure factor going vertical, and it starts at 0.1, 0.2, 0.3. So you're going to deal with 2 inches. So go to the bottom of the chart where it shows inches, and then find your 2, and then go up to 1.5 density. So 1.5 density, and where it meets 2 inches is about 0.67. You see where that is? So 0.67, not quite 70, but a little less than 0.7, so 0.67. Now, you found your exposure factor. So your formula is going to look like this now. It's going to look like time equals 0.67, okay, times 20 inches. Okay, 20 inches they've already given you as part of the formula. Remember, it says 2 inches of steel with a source to film distance of 20 inches. So you have your 3 numbers to plug in. 2 inches to help you find the exposure factor when you work up, and then 20 inches as part of the formula, and then 1.5. So 1.5 is not something you plug in. 1.5 is just something that you reference a chart to help you find the exposure factor at 2 inches. Okay, so 1.5. So this is what your formula looks like now. Time, write this down. Time equals 0.67, which is your exposure factor, times 20 inches squared divided by 40. Now, how do we get 40? 40 is what your answer is when you multiply those. So you go like this. Here's the calculator. So you end up with we still have to get another part of the problem, to be able to resolve the minutes. Okay, so first of all, what you have to do is anytime that you have a number that has to be squared, first solve that. Okay, so you're gonna square 20, and then hit your square button. See up here where I'm pushing? That's 400. Okay, so when you have your 400, then you can reverse it and go times 0.67, your exposure factor, times 0.67 equals 268. Okay, now you have one more thing to do. You divide by 40, divided by 40 equals, and there's your answer, 6.7 minutes. Okay, when you work this problem, that's you texting me. When you work this problem, look at the chart on RT lesson 15, page 3, okay? And try to resolve it with the instruction I gave you, and see if this works in your problems. All right?